Hi students, I am R. Mohan Raj in Department of Electronics and Communication Engineering, Assistant Professor, K.S.Rangasamy College of Technology. Today we are going to discuss about Gigabit wireless communication in the subject mobile communication and networking. So first we are going to see about what is the definition for Gigabit wireless communications and what is meant by standards and what is the standards providing organizations. So Gigabit wireless communication, which refers to wireless communication system which is capable of delivering data rates of 1 gigabit per second, that is 1 Gbps or higher. These systems are designed to support the rapidly increasing demand for high speed, low latency and reliable wireless connectivity. The term standards indicates the international technical specifications defined by organizations such as IEEE and 3GPP. So these are the international organizations which providing the standards for gigabit wireless communications and which ensures interoperability, reliability, security and global compatibility of gigabit wireless communication systems. And why the gigabit wireless communication system is important? So that is modern applications such as 4K, 8K video streaming, cloud computing, virtual reality, augmented reality, autonomous vehicles and smart cities which requires extremely high data rates. Wired connections cannot always provide flexibility and mobility. So only we are going for gigabit wireless communication, and gigabit wireless bridges the gap between high speed wired networks and mobile users. And in recent years, the number of wireless users and connected devices has increased exponentially. So, what are the devices? Means that is smartphones, laptops, IoT devices, smart sensors, and multimedia applications generate huge volume of data, placing significant demand on existing wireless networks. Traditional wireless systems such as 2G, 3G, even early 4G were primarily designed for voice communication and moderate data services. These systems are no longer sufficient to meet modern performance requirements. So these are all the traditional and old communications wireless systems, so which is not meet the performance requirements. So we are going for wireless communication systems. So the growth of data intensive applications. So what are the modern applications which requires high definition 4K, 8K video streaming, online gaming and cloud computing and virtual reality, augmented reality, video conferencing and remote collaboration, smart home and smart city services. These applications demand very high data rates, low latency and reliable wireless connectivity, which motivates the development of gigabit wireless communication systems. And the emergence of gigabit wireless communication. So gigabit wireless communications has emerged as solution to overcome these limitations. So what are the limitations to overcome by gigabit wireless communication system? Means that is using wider bandwidth, operating at higher frequency bands, employing advanced signal processing techniques and supporting next generation wireless standards. Next one, that is role of wireless standards. So what is meant by that is wireless standards ensure the interoperability between devices and reliable and secure communication, efficient spectrum utilization, global acceptance and scalability. Organizations such as IEEE, 3GPP play a crucial in defining gigabit wireless communication standards. And what is gigabit wireless communication? So gigabit wireless communication refers to wireless communication system that is capable of achieving data rates of 1 gigabit per second. So these designed to deliver ultra high speed data transmission without the need for physical wired connections. So the key characteristics of wireless communication systems is extremely high data rates. So that is greater than or equal to 1 GB per second, and low latency. So often in order of milliseconds or less, and high reliability for real-time applications, efficient spectrum utilization, and support for mobility and dense user environment. And what are the frequency bands used in gigabit wireless communication? Means sub 6 gigahertz bands. So which for better coverage and penetration, limited bandwidth, and next one is that is millimeter wave. So which is expressed as wave bands. So which operates in the range of 30 to 300 gigahertz. So which is very large bandwidth, short range communication, and requires line of sight or beam forming. Modern systems often use a hybrid approach combining both bands. The next one, that is rapid growth in mobile data traffic. So the number of mobile users and connected devices has increased dramatically due to smartphones and tablets, IoT devices, sensors, smart homes, smart cities, wearable devices. According to traffic trends, mobile data consumption is growing exponentially every year, so making high speed wireless communication essential. Next one, enabling technologies. So there is gigabit wireless communication is made possible by combination of advanced physical layer and network layer technologies. So this is offer very high rates and low latency and high reliability. So millimeter wave communication, so which uses the frequency bands between 3 gigahertz and 300 gigahertz, offers very larger bandwidth, enabling gigabit data rates suitable for short range communication and dense urban environment. Next one, massive MIMO. So there is multiple input and multiple output, which employs dozens or hundreds of antennas at the transmitter and receiver side. So what are the benefits in MIMO? Means that is increases channel capacity, improves link reliability, and essential for 5G and future networks. Next, beam forming. So beam forming means which focuses radio signals in specific directions and improves the signal strength and coverage and reduce the interference. So the types of beam formings, that is analog beam forming, digital beam forming, and hybrid beam forming. Next one, that is carrier aggregation, so which combines multiple frequency band into single high capacity channel, which enables higher data rates without requiring new spectrum, and which is widely used in LTE advanced systems and 5G systems. And advanced modulation and coding, which is the higher order modulation schemes. So that is 256 QAM and 1204 1024 QAM. The advanced coding techniques, that is LDPC, polar codes, and improves spectral efficiency and data throughput. Next, network densification. So deployment of small cells, pico cells, and which reduces the distance between transmitter and receiver and enhances the capacity and coverage in dense areas. And frequency spectrum of gigabit wireless communication. So the frequency spectrum plays a critical role in determining the signal strength, coverage area, interference performance of gigabit wireless communication system. To achieve gigabit data rates, the modern wireless system operates multiple frequency bands, mainly sub 6 GHz and millimeter wave bands. Next, the role of IEEE in wireless communication. So that is Institute of Electrical and Electronics Engineers is an international professional organization which is responsible for developing wireless communication standards. These standards ensure that wireless devices from different manufacturers can interoperate reliably and securely. In gigabit wireless communication, IEEE standards mainly focuses on wireless local area networks and wireless personal area networks. And IEEE 802 family of standards. So most wireless systems fall under the category of IEEE 802 working group. So which defines the physical layer, medium access control. So these layers determine the data rates, channel bandwidth, modulation schemes, multiple access techniques. And the key gigabit wireless standards are IEEE has developed several standards capable of supporting gigabit level data rates, which includes IEEE 802.11, that is Wi-Fi 5, WiGig, Wi-Fi 6, enhanced WiGig. So these are the standards designed to meet specific performance requirements and application scenario. And first one, that is IEEE 802.11, which is known as also known as Wi-Fi 5, so which support gigabit level data rates and high speed internet access in homes, public hotspots, etc. Next one, so there is operating frequency, which operate in the frequency of 5 gigahertz band, and it advantages less congestion compared to 2.4 gigahertz and more non-overlapping channels and reduced interference. Next one, that is WiGig, so which support multi-gigabit data rates or very short distances. It represents ultra high speed indoor wireless communications, and it operates in the frequency that is a 60 gigahertz millimeter wave band, and which provides very wide band up to 7 gigahertz. Thank you.